Okay, so today's lesson we are working on the cosine law. So lesson 5.4. So yesterday's lesson we worked on the sine law. Today is the cosine law. And just a recap, you use these two laws when you're dealing with triangles that are non-right. Okay, so they do not have a 90-degree angle. When you say non-right triangle, it just means a triangle where one of the three angles is not a 90 degrees. So in this first little paragraph we're saying right here, it's saying that sometimes the sine law may not be sufficient for solving all angles in a triangle, all acute triangles. For instance, in triangle ABC below, try to find A using the sine law. Well, remember the sine law requires an angle and its opposite side length. So if I look at this 60 degrees right here, well, if I look opposite of that, I don't know what this is. Okay, well that's fine, like maybe I might be able to solve it. Well, I also don't know what this angle is, and so I won't be able to set up my ratio to find that. Like I won't be able to set that 12 and that angle B up. Nor do I know what this angle A is, so I can't use my ratio to set up this combo right here. And because only one angle inside the triangle is known, it's not like I can figure out angle B or A by going 180 minus that. So in this problem, the sine law, you just can't use it, right? So this is where we get the cosine law. And don't worry about memorizing these formulas. I will provide these formulas for you, all right? But what I really want to highlight right here is that whatever side you put right here, whatever you set your equation up to, this has to be the corresponding angle here, and these will swap, okay? So what I mean is, like, let's say I was to solve, all right, if I drew my triangle out, and let's say I was looking for side length A in this case. Okay, so let's say I did A squared. Well, that means it's no longer C squared, it's A squared. That means this needs to be C squared plus B squared, my other two sides, minus, okay, well, look, here's an A, here's a B, here's an A, here's a B. So here's a C and a B, so that means this becomes minus 2CB. And then whatever side you put here, that's the angle that goes here. So this would be then 2CB multiplying cosine A, okay? Notice how A here, A here. And that's just the trick, okay? So it's not necessarily memorizing. You will be provided the formula, but do know how to rewrite it for different sides. Okay, let's just get right into it. Example 1, given triangle ABC. Oh, and actually, sorry, before I go into examples, the way you know you're dealing with cosine law is when you have three sides and no angles. And again, if you don't have any angles, well, in order to use the sine law, you need an angle and an opposite. So if you don't have any angles, 100% you cannot use the sine law. And then the other way is when you have two sides and a contained angle. So what that means is like your angle is touching the two sides. That's like what we see up here, right? Where you have two sides, side, and an angle between them, all right? As we just explored there, we weren't able to use the sine law, so you use the cosine. So let's look. Example 1. Given triangle ABC, find the length of C to 1 decimal place. So this is just like the problem. Actually, it's identical to the one above, all right? We have an angle C here, and we have side lengths that are adjacent to that angle, okay? So that angle is contained within that. We weren't able to apply sine law to this, so we know we're using cosine law. This question is saying find side length C. So I'm looking for this side length right here. So I'm going to set up my problem for that C. So that means I'm looking for C. So I'm going to write my formula as C squared And then this is A. A is 26 because it's opposite angle A. And that makes this one here B. So my other two side lengths, all right, are B squared or A squared plus B squared, all right? So your other two go there, minus 2 AB, because this was A and this was B, so that means this is A and this is B, times cosine C, all right? So if this is the angle, the side length I'm looking for, that angle needs to be here. Now let's fill in what we have. We don't have C, so it's still C squared, but you have A. A is 26, so 26 squared. You have side length B. Side length B is 12, so 12 squared, minus 2 times A, which is 26, times B, which is 12, cosine angle C, and we have that. That's 60 degrees. So notice that the only unknown in this problem is this C squared right here, is this C. So let's solve this problem out, and I'll show this one in steps, okay? So C squared is equal to, well, 26 squared, so 26 squared, that's 676, plus 12 squared, which is 144, minus 2 times 26 times 12, so minus 624 cosine 60. Okay, so C squared, let's collect our like terms, so collect your like terms right here. So C squared is 676. 676 plus 144, that is 820, minus, well, let's evaluate this. What is 624 times cosine 60? So 624 times cosine 60. So we are subtracting 820, we are subtracting 820 and by 312. So then you get, let's carry our math here, so we have more room. We have C squared, which is 820 minus 312, that gives 508. So C is then taking the square root of both sides, so this squared will cancel. You get C is equal to square root of 508, giving you 22.5, because it's only 1 to 1 decimal place. And our lengths are in centimeters. Okay? So really, the hard part about these laws is really just like the math behind it. Can you use your calculator properly, follow BEDMAS, and just go through it, okay? And I guess the other hard part is figuring out which law do you use. Do you use cosine, or do you use sine law? So obviously, this being the cosine law lesson, we're going to be using cosine law. So example 2. Triangle DEF. You have side length D being 62, side length E being 51, and side length F being 48 centimeters. Find the measure of angle F to the nearest degree. So let's draw this out. So we have a triangle. Perfect. Okay. We have a triangle where side length D, so let's call these vertices D, E, F, just so we know where to put our corresponding side lengths. So that makes this little d here to be 62. That means this is E being 51, and that makes this F being 48. Okay, well, the question is saying find angle F. Find this right here. So if you were to set up this formula, because we've only done the one where you have the side length on the side, so we're looking for angle F. Well, when you are looking for an angle, your unknown angle, you can use this one. But it's, again, just like in the sine law, these aren't different equations. This is just me taking this equation right here and rearranging it, to get it in the form of this angle right here, okay? All I did was, it's like this cos C right here is this cos C right here. It's just me using SAMDEB, the opposite order operations, to isolate for that cos C. So I'll show you that actually on this question. So we're looking for angle F. So ultimately, we want cos F to be there. So if this is cos F here, this is F, that means on the other side of the equation needs to be F squared, right? So F squared, because these need to be the same. They need to be in the same problem. So then that has to equal the other side lengths. E squared plus D squared minus 2ED. All right, well, we are looking for cos F. Like, ultimately, I want what cos F is equal to, not what F little f is. So let's rearrange this problem. Well, BEDMAS, or reverse order operation, says get rid of all your additions and subtractions. So that means get rid of this E, D first. So bring them to the other side. Bring them to the other side. That makes this F squared minus E squared minus D squared. So equal to negative 2 ED cos F. All right. So now we want F on its own, cos F on its own. So that makes this, we need to get rid of this negative 2 ED. So we divide both sides by minus 2 ED. So this cancels with this, and you get cos F equal to F squared minus E squared minus D squared all over minus 2ED. Here we go. So it's just a rearranged formula of the first one. That's all it is. But notice that we have a negative here on the bottom, but up top here, there is no negative. So there's a little math trick you can do. Well, not really a math trick, it's just factoring. So let's factor a negative out of the top numerator right here. So this would be cos F. If I factor a negative out, it's like me dividing this by negative 1, and this by negative 1. So taking all of those and dividing them by negative 1 just flips the signs. So it becomes E, positive E, plus D squared, and then that F was positive F, now it becomes minus F squared, all divided by minus 2ED. Because you have a negative on top and bottom, they cancel, and that is where that formula came from, okay? It's just E squared plus D squared minus F squared 2ED. Once again, you are provided this formula. But just to save some brain power, I don't want you to think that these are two separate formulas up here. They're actually the same thing. They're just rearranged for what you're looking for. So we have it in this form right now, where what we are looking for in this problem is this angle right here. So now let's fill in all of our information. Let's work with this over here. So we have cos F, perfect. We need side length E, so that is 51, and remember use squared, plus D, which is 62, squared, sorry, that's a 66, minus, and our F was 48 squared, all divided by 2 times E, which is 51, times D, which is 62. Okay, so let's do this in steps. Let's use our calculator and figure out what the numerator is. Okay, so what is everything up top there when you go 51 squared plus 62 squared, taking away 48 squared? So 51 squared equals plus 62 squared equals minus 48 squared. On the top side, I get 4,141. On the bottom side, 2 times 51 times 62, I get 6,324. So then I get cos F is equal to, well, 4141. Divide that by 6,324. I get 0. Did in green because it's still in green. 0.6548. And again, we're looking for angle F. So angle F is then the cosine inverse of this 0.6548. So cosine inverse, I get angle F to be equal to 49 to the nearest degree. So 49 degrees. There you go. That is cosine law for when you're finding an angle. So the next problem. Example 3. A triangular lot sits at two streets that intersect at an angle of 53 degrees. One street side of the lot is 29 meters, and the other is 42 meters. How long is the back of the lot, the third side, to the nearest meter? Okay, so just a long word problem that just pretty much says, find the side length right here. Find that one. Well, this is a problem that you know to be sine law because we have an angle, sorry, not sine law, cosine law, because you have an angle and you have side lengths that are adjacent, that are right beside it. And clearly there is no right angle triangle. You don't see any of that square right there. Okay, so this is not a right angle triangle. So this is a law problem, and you know it to be a cosine law problem. Well, we're setting up our formula to find this a right here. So it's a squared, and that means you're going to have equals on the backside here, cosine a, and then just fill in the blanks. So this 42 represents side length b because it's opposite of angle b, and that one is c. So b squared plus c squared minus 2bc times cos a. Fill in what you have. Well, we're looking for a. We are given b to be 42 squared. We are given c to be 29, so 29 squared, minus 2, side length b is 42, times 29, times cosine of the angle given, 53 degrees. Okay, and again, it's just a calculator problem now. So just 42 squared, so that's 1764, plus 29 squared, 841, minus 2 times 42 times 29, minus 2436, cos 53 degrees. So a squared is 1764 plus 841, 2605, minus, let's evaluate what this is equal to. So 2436 times cosine 53. So that's minusing 1466. So a squared then is 2605 minus your answer, 1139. And now take the square root of both sides. So this becomes a being equal to square root, that answer, 33.7, and how many to the nearest meter? So actually 34 meters. Here we go. Pretty straightforward, okay? Again, it's just a calculator problem. Really, the hardest part is just figuring out what formula do you use. So last question. While flying a helicopter, a pilot spots a water tower that is 4.8 kilometers away to the west. At the same time, she also sees a monument that is 5.6 kilometers to the east. The tower and the monument are separated by a distance of 7 kilometers. So find the angle separating their lines of sight. Okay. There's a lot here. Let's figure it out. So directions, all right? We're given these whole east and west directions. So if we have a compass, we have north at the top here. That makes this east, south, west. Never eat shredded wheat, all right? That's how you can remember it. So a helicopter pilot spots a water tower 4.8 kilometers to the west. Okay, so that means if you have a helicopter pilot That means they're spotting this 4.8 kilometers. 4.8 kilometers to the west. Same time, she also sees a monument 5.6 kilometers to the east. Okay, well, there is another monument that is 5.6 kilometers this way. 5.6. The monuments are separated by distance of 7 kilometers. Okay, so the distance between these 2 points right here, so my blue line, this is 7 kilometers. Find the angle separating their lines of sight. So I'm looking for this angle right up here. Okay, so let's redraw this triangle I've created. We have a triangle that has a side length here of 4.8. We have another side length right here to be 5.6. And then the side length over here, this one is 7. And I'm looking for this angle right here. So let's just give these some values to make our formula make more sense, or sorry, some variables. So let's just call this vertex A, B, and C. So that means this would be little b, this would be little c, and this would be little a. Okay, so we are looking for angle A. So we're going to use the formula rearranged for an angle. So we are going to be using this formula right here. So let's just look at the formula real quickly. You can see that this C right here goes there. Okay, well that means like its corresponding side length is what I'm subtracting up top. And then if that's an A and that's a B, you can see there's an A and B down here. So let's write the formula in that form. So I'm looking for angle A. So I have cos A equals, okay, so you have this fraction. You know because that's A, you're going to be subtracting its corresponding side length. And then you have the two other ones, the b squared plus c squared. And those ones also go on the bottom, 2bc. And that's just the way you can kind of think about how the formula is arranged. So now just fill in the blanks. You're looking for A. So you don't know that. You don't know what cos A is. But you know little b. Little b is 5.6. 5.6. So you have to square that value. You know little c. That one was 4.8. So square that. And take away little a, which was 7. So square that. And divide that by 2 times, well, little b is 5.6. And c is 4.8. So let's get our numerator and do this in steps, okay? Just don't make a mistake by just putting in your calculator wrong, so just take your time and write it out fully. So 5.6 squared plus 4.8 squared minus 7 squared. So if I do all that, my numerator up here becomes 5.4. And on the bottom, it's 2 times 5.6 times 4.8. So I'm taking 5.4 and I'm dividing that by 87.36. So then my A, actually I'll just write it this up. So cos A is me taking those two values and dividing them. So 5.4 divided by answer. So I get 0.06. That seems really small. Let me just double check my numerator is correct. 5 squared plus 4.8 squared minus 7 squared. Yep, okay, I did it correct. So 0.6, 5.4. Okay, so this was 0.618. Now to get angle A, you take the inverse cosine of both sides. So you just write it like this, 0.618. So angle A is shift cosine answer 86.5 degrees. And does it say to a certain, nope, doesn't specify how many decimals. Okay, so that means this right here is 86.5 degrees. And that's it. That is the cosine law, okay? So you have all of our homework here, which we will do in class. Bye for now.